Now introducing our third workshop. This one will be presented by Lingling Xu, Bingjie Xu, Shalini, Pochineni, and Li, who are all data scientists in Google's APAC team. And they are going to present the workshop Open Sourced Propensity Modeling Package, Accelerating Data-Driven Decisions.
Hello, everyone, and welcome to the workshop on propensity modeling. Today, we would like to share with you a scalable and a flexible package on propensity. This is completely open sourced, and we hope that this session will help make you more comfortable with A, what propensity is, B, its applications, and C, how to use this package in particular to solve for your propensity problem statements. I, Shalini, and my colleagues Bingjie, Lingling, Xu, and Rukshan are the facilitators for this workshop. We come together from 4 different markets: India, China, Southeast Asia, and Australia. A quick introduction to myself. I am a data scientist with Google, working in the Google Tech organization. I have around 10 years of experience working across analytics and data science fields. My interest areas are risk, fraud, prevention and management, and natural language processing. Over to Bingjie for a quick introduction.
Thanks, Shalini. Hi, everyone. My name is Bingjie. I'm a data scientist based in Beijing, China, who work with Shalini on the data science APAC team at Google to help our business partners in Greater China on solving their business challenges by utilizing advanced machine learning and data science technologies. Today, I'm very happy to give the presentation together with Shalini. Hope you all enjoy it. Over to you, Shalini.
Thanks a lot, Bingjie, for that. Moving on, given there is a lot of content to digest on propensity, we have planned this workshop across 2 sessions. The first session, which we have today, covers introduction to the concepts of propensity modeling, getting to understand when to use propensity and how to use the propensity package, which is called Compass. We will take you through the details of the workflow, the data sets, and the data preparation, which involves a unique concept called windowing pipeline. In the second session, we plan to cover in detail the ML model training, evaluation, and insights generation. We will then take you through the media experiment design, followed by model activation. There, we will take you into the world of Compass, and you will find some very interesting topics, along with a demo of the existing package. So without further ado, let us kickstart the session. I will take a step back and talk about some commonly discussed business marketing problems. These are usually centered around user acquisition, user engagement, or user retention. Let us take a few examples. My call center is overwhelmed with traffic. How do I prioritize who my best leads are? I want to cross-sell my products, but how do I know who my high-value customers are? I want to roll out a focused offer towards users who will churn, but how do I identify these users? I want to adjust my bids as per user retention, but how do I know which users will retain? You will find a multitude of such questions being talked about in your day-to-day business. Interestingly, all of these problem statements we spoke about have an underlying layer of propensity running across, and they can actually be reworded to become propensity modeling questions. So essentially, if someone wants help in identifying which set of users/customers will perform a certain action in the future, that is when propensity modeling becomes relevant. The most important role of a data scientist here is to help the business identify and realize which business problem statement is potentially a propensity or a general data science problem. Now, let's try and reword the business problems we saw on the earlier slides and make them propensity problems. My call center is overwhelmed with traffic. How do I prioritize the best quality leads to reach out to? So now I ask, how is lead quality defined? Lead quality, say, is defined by the company as a user's chance to becoming a customer. So now my problem comes down to computing what is the probability of every lead to convert. Similarly, churn. I want to roll out a focused offer towards users who will churn. Now my question is, how do you define churn? Say churn is defined as a user not being active in the next 30 days. My problem now comes to computing the probability of a user to be inactive in the next 30 days. You can try out converting more business problems to propensity. Now that we are clear on how to identify propensity opportunities, let us focus on defining propensity and understanding the steps to building a propensity model. Propensity model is a set of approaches to building a predictive or a forward-looking model. The output of such a model is the likelihood or propensity of a set of users performing a certain action, which we define, in a well-defined time period in the future. By learning from past behaviors from a well-defined time period in the past. What is important and usually missed out often is the well-defined time period. While formulating the problem, please make sure you understand and identify the relevant time periods for a specific use case of interest. This should include A, the past time period which one should learn from, and B, the future time period for which prediction holds true. If we now move on to the steps of building a propensity model, it starts with the most important step of defining the problem and making it a propensity problem. What are you going to predict? What are you going to base this prediction on? What time period will be relevant? Will the output in the shape and form it is help in driving business metrics of interest? All these questions contribute to defining the problem statement. Once we define the problem, the next step is to identify if the relevant data is available and if it is robust enough for modeling. We then do exploratory data analysis, data cleaning, label, and feature generation. On top of this, we then train a model to uncover any patterns from the data. The trained model is then used to give predictions on a new set of users or give a refreshed prediction on an older user base. Now that we have the predicted output, the estimated propensity scores can then be used to make data-driven decisions, such as improving remarketing or acquisition campaigns in order to optimize key business objectives, such as, say, increasing conversions or reducing churn, and so on and so forth. The insights extracted from a propensity model are also helpful to understand key drivers that are highly correlated with or caused on the target event of interest, some of which would lead the business to take useful actions, which are called the actionable insights. There are, however, some limitations of propensity. It does not take into account the effect of the treatment itself. The treatment, meaning the marketing campaign, which has the incentive or the promotion applied. This may lead to going behind people who would have spent money anyway, or might not be really impacted by the marketing campaign. So the communication angle is what is not baked in to propensity. Even with these limitations, propensity model is a very powerful tool in data science. Now, we at Google, hence, have built an open source package which helps develop end-to-end propensity models, which can then be used by business for activation. This module covers the data preparation and the modeling steps highlighted here, which includes exploratory data analysis, machine learning data preparation and pre-processing. It also covers aspects of model training, model evaluation, and diagnostics. You will also see interesting notes about the activation segment. I want to highlight here that in order to get good results out of a modeling exercise, model evaluation is critical and more important than even building the model itself. Please do spend enough time understanding the techniques to evaluate a model which you build. Now, let me give you a high-level overview of the package itself. To run the package, you will need to first prepare a data set with customers' past behavioral data, such as demographics, transactional, or browsing behavior over time. This data should include a sufficient number of examples of the action to be predicted and the fields that capture user behavior or characteristics prior to that action. Now, what is the sufficient number and how to treat unbalanced data sets is a very extensive topic, which you can actually find a lot of great material on. This action event is called the target, label, or the response. It is recommended to use at least 1 year's worth of data, ideally 2 years worth of data, to capture seasonal patterns of the user. You will also need access to the GCP, which is Google Cloud Platform, and need to update some permissions. I would like to highlight here that this package works on Google Cloud Platform, and we assume through the package that the raw data is already available in the BigQuery environment. The details are present on the GitHub. So let me quickly give you a tour of the same. When you go on to GitHub, you will actually see within Propensity a README file, the link to which is provided here in the slide. The README document gives you an extensive detail about introducing what propensity is, talking about the requirements to run this package in particular, the permissions which need to be granted. It also takes you in a lot of detail through the steps of building a propensity model. For each of the steps mentioned, the corresponding notebook is attached here as quick reference. You will also find that each section is detailed and will give you a lot of interesting material to improve your understanding of propensity. Also, if you take a step back and go into the propensity folder, you will find these notebooks present here. Each notebook is structured in a very similar fashion. Let me give you a brief of how each notebook is structured. It starts off with an introduction and the requirements. The first module is always the module containing the libraries you have to install in order to power the specific package and the notebook. Post this, you will need to set up the parameters. Parameters are the ones which are the variables used in this particular notebook. So you can feel free to update and adjust basis your requirement. Once you set up the parameters, the rest of the flow will be relatively seamless. Here, a specific data set, which is the standard GA360 data schema, has been used to run the package. I will give you a lot more detailed walkthrough of the same. we see that the data source used in the package, right, was a Google Analytics dataset. You can actually use both a Google Analytics dataset or even a CRM dataset. The module, however, uses Google Analytics data for table and feature references. And let me now give you a little more of context on how Google Analytics data is and how it is overall structured. Google Analytics data essentially captures every single interaction between the user and the website or app. Hence, it actually has multitude of data points and signals for each user, even if the user is not logged in. So the user here can be a customer or just someone who is actually checking out your web page or an app. This helps power a lot of use cases for people who have not even become your users so far. Data points on Google Analytics are seen across session details, time spent on the site, geolocation, device details, from which they are interacting with, and so on and so forth. With proper UTM parameters configured, analytics also records the source of the traffic and other campaign details for paid traffic. One can even upload their own CRM or custom data into Google Analytics. And all the analytics data can then be exported on a real-time basis to BigQuery, which could then be used for modeling purposes using the package. The sample data, which is being used in the propensity package, is the Google Merchandise Store data. I have shared here a couple of links which will help you understand the export schema and the GA data sample set. Let us take a little more detailed view into the same. So if you look at the link which has the sample data set, it gives you an understanding of how to access the data, where the data comes from, and also how to query the data. If you move on to the export schema, that will give you a detailed walkthrough of how the table is structured, what rows are present in the table, and what are the columns in the table, including the specific field name, the type of the data, and the description of the data. So these are very interesting links and will be very useful to go through them, as you'll hear a lot more about the data set being used in the session 2. Now, I would like to hand this over to Bingjie to share more on the tips and tricks on data preparation. Over to you, Bingjie.
Thanks a lot, Shalini. So as you can see from Shalini's introduction, propensity score modeling can be very useful and powerful in solving business challenges in several scenarios. In the rest of this session, I will introduce you the steps of doing data preparation work before modeling, and also provide you some very useful open source packages developed by our colleagues at Google to help you implement those steps in a more time-saving manner. Next slide, please. Like any other machine learning or data science project, the very first step begins with the exploration on the raw dataset to help us understand the basics of our data. To help you conduct the exploration more easily, our colleagues at Google have created an open source package on GitHub, which includes a notebook for EDA. This notebook, highlighted on the screenshot, will help you do mainly 3 things. Firstly, it helps you to check feasibility of building a good propensity model based on your data. Secondly, it helps you to inspect dataset fields in order to identify any relevant information for features and targets. Thirdly, it performs initial exploratory data analysis to identify insights that helps you with building a good propensity model. Next slide, please. Here is a screenshot of this notebook. Due to the time limitation, I will skip the full details of implementation. Highly recommend to check it out when you have time. Next slide, please. So next, after exploring the raw dataset and confirming there is no significant issues with your data, we will move on to the data preparation steps. Let's consider, so basically, here is a screenshot of the machine learning dataset. On each row, it contains user ID, the snapshot date, the features and the values, along with the labels. So next slide, please. Let's consider a propensity to purchase model using GA data as an example. The machine learning ready datasets, as shown on the last slide, can be generated from the data preparation steps from raw data, and the implementation can be done by the notebook as highlighted on the screenshot. So basically, let's take a look at the details about how to generate the machine learning ready dataset. So basically, on each day in the raw data, we will have the user's browsing behavior data on the user level, such as the count of the visited pages, the number of purchases, and the user's device and location information during the lookback window. Next slide, please. Previous slide, please. Thanks. To build the features for modeling, we will utilize aggregation operations on both numerical and categorical data over the desired lookback window. Here in the example, we are selecting 3 months as an example. You can always customize this parameter based on your needs and the distribution of your data. Next slide, please. Also, for the target of the model, we will label each user as purchased or not based on the user's purchase activities during your selected prediction window, such as 1 month ahead of each snapshot date, as shown in this example. Again, highly recommend you to check out this notebook as highlighted on this screenshot. Next slide, please. So, after conducting the aggregation operations on each snapshot day, we will have instances of all the user's features and its values as shown in the table on this slide. Next slide, please. Then we will repeat the previous aggregation operations with the series of selected snapshot dates based on your preferred sliding window. As shown on the right-hand side of this slide. So this sliding window length will identify the distance between 2 adjacent snapshots to generate a richer ML dataset, as shown in the table on the right-hand side of this slide, which will contain more training data for building a model. Also, it captures any seasonality effects and trends in your historical data. Next slide, please. For all the steps regarding data preparation, you may find it time-consuming to do it manually from 0 to 1. So we have a notebook that can handle this implementation for you. The link and screenshot of this notebook are displayed on this slide. Due to the time limitation, I will skip the technical details in this notebook. Next slide, please. Next, I want to introduce a concept and a tool called Machine Learning Windowing Pipeline, developed by our colleagues at Google to help you build the machine learning dataset by taking multiple data snapshots over time in a very fast way. Basically, it contains 4 main steps, as shown in the graph. The first step is to extract the input data. Secondly is output data for visualization. The third step is to create the window dataset. And the last step is to generate the features for building the model. It has been built to run on Google Cloud BigQuery, and the input data is expected to be available as a BigQuery table. The developer can simply specify the time-related input parameters, such as the starting and ending dates of the snapshots, the sizes of the lookback, prediction, and sliding windows. Also, you can specify the variable names with the desired aggregation functions to generate features and labels before doing the modeling steps. Also, it produces very useful visualization on instances, facts, and features data to help you better understand your data and to build a good propensity model. Next slide, please. So now, the package is already open source. You can run it on your local machine. Before running the module, you have to do 3 steps preparation work. Firstly, you have to log into an existing Google Cloud project or create a new one. Secondly, you have to make sure your CRM, GA, or Firebase dataset is in a BigQuery table of this GCP project. Thirdly, you have to install the ML windowing pipeline by running the pip install command line as shown in this stack. So the link and the screenshot is for you to give a quick look at the package. Highly recommend you to check it out offline and run it on your local machine when you need it. Next slide, please. Let's take a deeper look at the visualization produced by this package to help you better understand how the output looks like. So by visualizing the target distribution over time, we can check the consistency of the dataset and detect if there is any seasonality or trends we need to pay attention to in the modeling steps. This visualization can also be very helpful for you to determine which time periods we should use during model training steps. Next slide, please. Next, let's take a look at the fact visualization. A fact data is in the format of user, timestamp, variable, and value format. For the fact visualization, we can utilize it as a reference to select stable variables over time to generate features before modeling. For example, on the right-hand side of the slide, we are showing the package produces the plots for both numerical and categorical variables based on your needs. Next slide, please. Then, after you determine the time period for building your model and decide the variables to use for generating features, we can move on to the feature generation step. In this step, you will have more control of selecting the GA variables, feature type, and the input values based on your prior knowledge or the exploration of the facts table. More specifically, for generating features from raw data, for numerical feature variables, we can utilize aggregation functions such as sum, mean, max, and average. And for categorical variables, you can utilize aggregation functions such as proportions, counts, and mode based on your needs. Next slide, please. After generating the features, we can utilize the package module to visualize the features to help you further understand the consistency and the stability of your data over time, and also help you to early identify any significant issues such as label leakage in your dataset. For example, on the right-hand side of this slide, we can compare the 2 groups of users using the box plots for numerical features and histograms for categorical features over time to detect if there is any issue with the features between the two groups of your users. Next slide, please. Finally, like any machine learning modeling process, before training your model, we have to separate our datasets into training, validation, and testing datasets at a proper ratio, depending on your needs. This can be handled by the open source notebook as shown in the next slide. So basically, in the third notebook in the package, ML data pre-processing step, we will help you to conduct the data splitting step. The link is provided on the slide as well. Please check it out when you have time. Next slide, please. So that's all for the overview of propensity modeling, data preparation steps, and the machine learning windowing pipeline tool introduction for helping you to build a propensity model. I hope you find this content and the tools useful before we go through the details of modeling in the next session. And hopefully you can apply some of the knowledge and tools in your day-to-day work. For the rest of the modeling process, in the next session, our colleagues Lingling and Xu will provide you more details. Please stay tuned.
Thanks a lot, Bingjie. I would like to highlight here that in the next session, we will take you through a lot more detail into the modeling exercise. We'll also be sharing parts on the activation piece, which includes experiment design and analysis. Thank you so much for your time and have a good day.
Bye-bye.